Hey there, and welcome to Intro to 3D Printing. This brief introductory class will go over the basics of the technology, what it is, how we go about finding and preparing 3D models for printing here at the library, and a little bit about how our machines work. So before we get started, I like to talk about what exactly is 3D printing. Essentially, it is additive manufacturing, which means building three-dimensional objects by adding layer upon layer of a building material. A machine reads data from a design file and then lays down successive layers of material to build that design in real life. This is a close-up video of what it looks like in action. A little bit about the history of 3D printing. This is the first 3D printer. It was called the SLA-1, and it was invented by a guy named Chuck Hull. In the early 80s, it would take about 6 to 8 weeks to get a prototype or a part made using the tooling processes they had at the time. So a machine that could print a part in just hours was a major breakthrough within the manufacturing industry. While the technology has existed in some form for 30 years, its first uses were focused on prototyping and as a way to visualize models in pre-production. But since then, additive manufacturing has evolved and is being used to create products across almost all industries. Just as a way to show some different forms of 3D printing, this is a process called L.M.D, laser metal deposition. And so this is actually 3D printing with metal by superheating metal shavings with a laser. And here we can see additive manufacturing being used to produce ceramics. So now let's talk about our 3D printer. In the case of the library, our 3D printer is a MakerBot, and the build material is a plastic filament called PLA. The extruder heats up to about 230 degrees, and a motor pushes that plastic filament through that heated extruder nozzle. As it's extruded, it cools and it adheres to the layer underneath. This specific method is called fused filament fabrication. In this infrared video, we can see the process in action. The extruder block is glowing red hot, and as the plastic extrudes, you can see it start to turn yellow almost immediately, fusing to the underlying layers of plastic beneath it. So let's take a look at the parts of our MakerBot. First of all, here's our extruder. Now this is the piece that grabs your filament, pulls it in, and pushes it through the heated nozzle. This is the part that is building up every element of your 3D print. So this is the most primary piece. It's mounted on what's called the gantry system. These are metal rods that are on the X and Y axis, and this is how the extruder travels to lay down your layers. The LCD panel and keypad are the main way we interact with the 3D printer. This is how we select files, and we run different diagnostic processes like loading and unloading filament. So this rectangular piece of acrylic is what's called the build plate. This is the surface that all of our 3D prints build up off of, and it snaps into the build platform. Behind it is the threaded Z-axis rod, and this is how the verticality of your 3D print comes together. Every time the extruder prints a layer, the build plate moves down a fraction of a millimeter on that threaded Z-axis rod, and the next layer is extruded, and so on and so forth until your object is finished. The filament spool sits on the back on a little spool holder, and it unwinds as you print. It feeds up through this clear plastic guide tube that goes alongside the extruder cable, and it leads into the extruder itself, which has a small gripper motor that is constantly pulling that filament in throughout your 3D print. So before you can 3D print something, you have to have the 3D model that you're going to print. So this is how we go about finding and preparing 3D models to be printed. One of the first great resources is a website called thingiverse.com. This is a website that's run by MakerBot, and it's a compendium of 3D models created and shared from makers all over the world. You can find just about anything on Thingiverse, as well as tips on how to print it, examples of successful prints of that object. You can see comments from other makers that'll give you valuable info about settings to use and details like that. So once you find a 3D model that you want to print, you can click on Thing Files, and you can download the 3D model. Now that's a great resource for finding 3D models that have already been created. But say you want to make your own 3D model from scratch. Well, there's some good free 3D modeling softwares out there that you can choose from. A great one to start off with is a website called Tinkercad. This is basic 3D modeling that's in browser. You don't have to download anything. You don't have to install anything. They present a full tool set for creating your own 3D geometry. There's built-in tutorials. So if you're just starting out with 3D modeling, this is a great place. You can even import 3D models and edit them. So that means if you find something on Thingiverse, you can bring it into Tinkercad, you can edit, modify it. So let's take that comb that we found on Thingiverse, we'll bring it into Tinkercad and make a few changes. And then we'll export it again for 3D printing. Now, if you're looking for free 3D modeling software that is a little more in-depth, some great alternatives are SketchUp, which you can find at sketchup.com. This is a software that's great for architectural designs and getting a little bit more detailed with it. And then Blender. Blender is at blender.org. And not only can you make your own detailed 3D models, but it's also a great platform for animation. People use it for game design, so it's pretty versatile. So those are a few good resources, but no matter where you get your 3D models from, something to keep in mind is before they can be 3D printed, they need to be either .stl or .obj file format. Then they can be imported into the MakerBot software that will slice our 3D model into the layer-by-layer instructions that tell our machine how to build it. So this is the MakerBot slicing software that we're going to use to set up our 3D print. You can see here there's a virtual build plate of the Replicator 2. And if we were preparing this for a different printer, we would go down to the bottom right corner and we would select a different model. You can see here we have some options. We're going to stick with the Replicator 2. So up in the top left corner, we're going to hit Add Models to bring in that comb that we downloaded. Now that we have the 3D model loading into our slicing software, we can go about editing the print settings. So let's take a look. If we click on the little gear icon over here on the right, we get some of the basic print settings. And looking through them, you see supports, raft, extruder temperature, and things like support density. All right, so let's take a look at supports first of all. As 3D printed parts are built layer by layer, a previous layer to build upon is required. So certain 3D models or shapes that have areas of overhang or parts that have to be printed with nothing underneath them will have to have some kind of support. So checking the support box creates an automated scaffolding. The software evaluates the shape of the model, and where needed, it puts in these thin support layers that when you're done, you can snap off. And farther down on the settings, you can see support density. If your supports are too dense and they're not easy to snap off or they're getting stuck to your model, you can reduce that density And similarly, you can increase that density if you need them to be stronger. You also see a checkbox here that says raft. The raft is a plastic platform that the 3D printer lays down first so that your first few layers of your print stay in place. If your 3D model has small points of contact on the base where there's not a lot of opportunity for it to adhere to the build plate, it can get knocked off, it can become unstuck, and then you've compromised your whole print. So the raft just takes an outline of your shape and lays down a solid bed of plastic so that when you start printing the first layers of the actual model, they fuse to that plastic and you get a successful print. Once again, these rafts, just like supports, will be removed after the print is finished. The extruder temperature is simply how hot the extruder nozzle is going to get to melt your plastic. The default is about 230 degrees. If you find that the plastic is melting too quickly and it's your 3D model, your print is stringy, you can reduce that temperature. I'm going to stick with the default. Now our little credit card comb that we're going to be printing today won't need supports and it won't need a raft. It's pretty flat. It's going to be very simple to print that building straight up off of the platform without those extra settings. So now that we kind of have our settings the way that we want them, we can go into the actual slicing of the model. So to do that, we're going to go to the top right corner and click on this icon of the little clock to generate our estimate and our print preview. This is going to start slicing the model into the individual layers that the 3D printer is going to use to build your object. This is called the toolpath file. And now that it's fully sliced and our toolpath file has been created, we can see some key information. Looking at the material estimate, it tells us that this 3D print will take 6.59 grams of filament, and the time estimate tells us it'll take 34 minutes to print. Now the library uses this information to come up with the rate that we charge patrons to print here at the library. We have a $5 service fee plus 10 cents a gram. So you can see here, based on the material used, it's going to be about 65 cents in addition to that $5 service fee. So now we're ready to export our toolpath file. For printing, we're going to click on Export down in the bottom right corner. And we're going to save it to an SD card that's going to be placed into the 3D printer. Now remember, this is no longer a 3D model, this is a toolpath file. Just the instructions for the printer itself. Alright, so now we're going to load our SD card into the 3D printer, and we're going to load the filament into the extruder. I'm going to navigate to the Utilities menu to start the filament loading process. This preheats the extruder, and once it's ready, we can insert the filament where the gripper motor will grab it and push it through the heated nozzle. Now that our filament's loaded, we can go ahead and select our file and start our print. And about a half hour later, we have our finished credit card comb. Check out our library website for more information, including our printer policies and rates, and also an online submission form where you can send your 3D models to the library to have them printed. Thanks for watching, and we look forward to seeing the cool stuff you guys create.